So I will be talking about 3 interoperability solutions. I will discuss entire screen, yes. So I haven't prepared slides. I have prepared an Excalibur because I need to zoom, and I cannot zoom in slides. But what I will do in this talk is discuss 3 interoperability protocols, specifically layer 0 across and superchain native interop, and discuss their risk. So a risk assessment of these 3 interoperability protocols. So for context, I'm Luca. I do research at L2Beat. I usually look into L2 architectures, but interoperability is a big thing, and we might expand our scope to interoperability protocols. So this is like my attempt on trying to read the smart contracts of these protocols and assess the risks, because it's very important, right? So let's start with layer 0. Layer 0 OFTs. So OFTs, an OFT is a special type of token that is used by layer 0 to enable cross-chain bridging, right? And the idea, the high-level idea between of layer 0 is very simple. You have a set of validators. They're called DVN, that stands for Decentralized Validator Network. They're not necessarily decentralized, so I wouldn't have called them DVN, just VN, but you know how crypto marketing is. So you want to send a message. Let's say you want to send some tokens from Base to Arbitrum. You burn your token on Base. The DVN will notice that you've done this action, and they will relay this information on the other side, right? So you will expect some sort of signatures being verified from this DVN, and after these signatures are verified, tokens will be minted. And if tokens will be minted on the other side by these validators, it means that you need to give minting rights to the validators. And if you give minting rights of your token to the validators, it means that you're enshrining the layer 0 infrastructure within your token. So every risk that the layer 0 infrastructure has, also your token has. So every user that holds your token inherits all the risk of layer 0 at all times, which is, and let's discuss these risks, right? So in practice, when you want to bridge your funds, what you will do is you call a send on your OFT token. This send calls the endpoint, and the endpoint is a smart contract on every chain. Every chain has one endpoint, and this endpoint establishes, what to do, how to relay the information to the other chain. In particular, it defines 2 libraries, 2 smart contracts: the send library and the receive library, one for sending and one for receiving message from the other chain. And the thing is that each OFT token can define different libraries, right? So the security of a token depends on these 2 libraries, and for each token you will need to review these 2 libraries. It's even more complicated because it's not just 2 libraries for each token, because the token can define the libraries depending on the other chain, right? If I want to send from Base to Arbitrum, I could have this set of libraries, but if I want to send from Base to Optimism, it could be that there are 2 different libraries. So the library that you use is dependent on the path that the token is taking. And if you are holding the token, you have the security risk of all the libraries, of all the paths that these token can use, right? So it's a lot of work to review the security of a token because, again, you need to review all these libraries. And the number of libraries scales with the number of chains times chains, which is the path of all possible paths that a token can take. Since this is a lot to configure, layer 0 provides default libraries. Most of the token use default libraries, which are these ones, the register libraries. So if the token does not override these libraries, we'll use the default ones. And if you look at these default ones, what they do is that they define these DVNs, right? This is the default library, again. A token could define something that is completely different, completely custom with its own security. But looking at the default one, what these libraries do is that they define the number of confirmations that you need to have to like confirm a message on the other side, which DVNs are required, which ones are optional, and what you do is basically, let's go through the path. You send, you call the endpoint knows what the send library is. It will call the send library, there is some information, and it will emit an event. This event will go through the DVNs. They will do something that is defined on the receiving library. And like the receiving library just defines which DVNs to use, but the DVN code is custom, so you would need also to review the DVN code. And then when you do this, there is an event that gets emitted, there are some executors that do other stuff, but at the end of the day, an LZ receive function is called that then means the tokens, right? And the thing is, all these contracts are owned by a 3 out of 5 multisig, meaning that, again, most of the tokens use default libraries. These libraries can be changed like to malicious one at any time by these 3 out of 5. And moreover, even if this 3 out of 5 is honest, the token itself can update the libraries without time blocks most of the times. So like assessing the token on an OFT is very complicated. Most of the time, again, it's not very secure. And the problem is that you're taking the risk just by holding the token, not only when bridging, right? And we wrote about this in an article like 2 years ago, where we discussed that if every token can do whatever they want, this is not very secure because they use, like you put a lot of work on the user that needs to verify everything, and it's just like not feasible. Like the user will not do it, right? And we also did like a proof of concept. We created a token, and we tried to use the standard infrastructure, like the default one. We showed how you can bridge this token, and then we rugged this token. Like we were the only owners, so like we didn't rug anyone. But as a proof of concept, we showed how easy it is to rug an OFT token. It's super easy. And what happened is that Layer 0 contacted us and said, oh, okay, look, maybe we can collaborate. We can create, because we don't just yap and complain. Okay, we also want to improve the space where we can. So we tried to collaborate with them to build this dashboard. And I bet that none of you know this dashboard. And this is a dashboard that shows for each token in the Layer 0 network if they use the default configuration, if there is a custom one, if there is a custom one, what it does, and then how many times this configuration have changed. And none of you have probably seen this because we abandoned the project. And why we abandoned the project? We abandoned it because, first of all, this is very complicated. If you want to track the security of OFT tokens, you need, again, this scales, the infrastructure scales with the number of tokens times the number of chains times the number of chains, because it's all the paths times the number of tokens. And then Layer 0 really didn't care about this. There were a lot of contracts that were not verified. They didn't help us. So like, if you don't care, like, we can do all this so far, right? So this is Layer 0. Let's go through. Yeah, I mean, the DVN, what the DVN code defines is basically a set of actors that sign messages, and you have a threshold, and if you meet this threshold, you relay the message. Like it's a multisig bridge, more or less. It's a multisig bridge, a configurable multisig bridge with no shared security. So going over to across is different. Again, the high-level idea is simple. The idea is I want to send some tokens. Multiple what? Yeah, like each token can define which DVN they use for security. The default one, I don't remember. I think it's just 2 DVNs. One is Google and the other is Nethermind, I think. But any token can define which DVNs to use. But most importantly, the default ones can be changed at any time. So like the security can change at any time. And also the token itself can change. So both Layer 0 and the token can change which DVNs to trust. And they can change it to a malicious one at any time. So going through across, the high-level idea is I want to send some tokens. Instead of enshrining the infrastructure of a bridge inside the token, I will use canonical tokens, but I will take the funds on the other side from a liquidity provider. The liquidity provider will front the liquidity for me very quickly, and then the liquidity provider will like use the slow path to actually get my funds that I wanted to bridge, right? So the idea is, again, very simple. I deposit. There is this spoke pool verifier. You deposit the funds in this spoke pool. An event is emitted. There are solvers or liquidity providers that get the event. They will front you these funds, like from out of their pocket. And then what happens is that you need to tell to this contract that this fill has happened. And the way that it works is that there is an event. There is this actor that is a data worker, which is permissionless. If you stake, because there is like an optimistic protocol to check the information, like to relay the information that a fill has happened. So what you can do is that you can propose these bundles of informations of fillings. You can dispute them, and if they're not disputed, you can execute them. And there is a dispute protocol, which I think is based on the UMA protocol. There is a 1-hour challenge period. So the risk of the protocol depends also on the risk of this optimistic protocol, right? 1-hour challenge period is, shortish, I would say. Like you're not protected from censorship attacks if you're censored for more than 1 hour. But the cool thing about this protocol, okay, anyway, like when you execute the protocol, what will happen is that the funds will be settled across chains to repay liquidity providers through the canonical bridges, right? So what is the risk of across? The risk is, the settlement protocol. But the cool thing is that the risk is mostly taken from liquidity providers. Like you as a end user that want to bridge, your risks ends when the bridging ends, right? If you get your tokens, you don't have the security risk of across anymore, which is very different from layer 0, what we discussed before. But these risks are present for liquidity providers. Like I would say, liquidity providers are still users. We would like to protect all users, including, liquidity providers. And the risk that liquidity providers takes is this challenge protocol, which, depending on implementation, could be more secure or less. And but mainly the fact that all the contracts are upgradable. All the contracts are upgradable by the owner of this hub pool. This owner is, again, a 3 out of 5 multisig that can upgrade all the contracts, change the configuration of the paths that the settlement protocol takes, and rug all liquidity providers at any time. Like, this is instant, again. So, we don't have stages for bridges, but like, I guess it's easy to imagine what stage this protocol is if we were to do it. But also, let's say that it is not upgradable. The fact that you want to be able to change, let's say, the adapters, because let's say Arbitrum upgrades their contract, they change the interface. You want to be able to upgrade the adapters that allow you to connect to these canonical bridges. But ideally, these adapters contracts are controlled by the same governance as the chain that you're using, right? It would be cool if the Arbitrum adapter is controlled by the Arbitrum governance. Right now, everything is controlled by across. So yeah, that's the risk of across. The next one, another thing. There is this ERC that across is pushing with Uniswap to standardize cross-chain intents, which is based on like it is an effort. My understanding is that it's an effort to standardize what across is doing. We were asked to support this publicly as L2Beat. We decided not to because it doesn't really discuss security. Like L2Beat is about discussing security. You could implement this standard in very secure ways or like very insecure ways. So like personally, I like it. I think it's a nice thing, but it's important to notice that again, it doesn't talk about security. You can implement this in very secure ways or not. And then the third type of interop solution that I want to discuss is optimism native interop. This is for arbitrary messages, which is interesting. But the high-level idea, the high-level intuition is that you enshrine the interoperability protocol within the derivation rule of the rollup itself. In the sense that if I want to send a message from OP mainnet to Unichain, I will, have initiating message on one side. I will have a executing message on the other side. And if a chain like Unichain includes an executing message that for which an initiating message doesn't exist, the chain will reorg. So it will be structurally impossible to have unsafe calls, right? So the way that it works, the very cool thing that I really like about superchain interop is that they use events as initiating message. You can basically execute on any other chain, consume any event from all the chains in this cluster, right? You define in your dependency set which chains you support. You want to listen events from. This dependency set can be different. For example, Unichain might listen to OP mainnet events, but OP mainnet might not listen to Unichain events. So this is unidirectional. And the way it works is that I do something on some contract, some event is emitted. I can consume this as a message on Unichain. And the way that I do this is I call the cross L2 inbox, which is a contract that by specifying the ID of the event, and the ID is defined as origin, block number, log index, timestamp, and chain ID, which uniquely identifies an event. This contract will make sure that you have this, that the chain, the derivation of the chain will not include an executing message if there is there is not a valid initiating message on the other side. The cool thing about events is that they're broadcast. You don't have replay protection by default, or what they call domain binding. So all chains can consume the same message multiple times by default. You need to construct additional infrastructure to provide replay protection, domain binding. OP-Stack provides this infrastructure by default. They call it the L2 to L2 cross-domain messenger, which adds nonces and this domain binding. And then on top of this, you can build a token bridge, right? So you have the superchain token bridge. You send a token. This superchain token bridge makes use of the L2 to L2 cross-domain messenger, which provides, again, replay protection and domain binding. An event is emitted, and this event will be consumed on the other side by calling, again, the L2 to L2 cross-domain messenger with the ID of that event that will, again, call the superchain token bridge to mint the token on the other side. So in this case, you will burn and mint tokens. And if you burn and mint tokens using the superchain token bridge, it means that you need a custom token. So this doesn't work for all tokens. You need a special type of tokens that exposes these functions to burn and mint, which is called the superchain ERC20 in this case. And I really liked the LE talks before about dependencies of confirmations, because the same thing is happening here. So the question is, when can another chain accept, run an executing message? You can do this only if you're sure that the other chain will eventually include an initiating message. So you could use pre-confirmations. So before the data is posted on L1, but if this chain reorgs, your executing message will not be valid, which means that your block will be considered invalid and the chain will reorg. You don't want to reorg, so you will accept pre-confirmations only from the chains that you trust. If you don't trust them, you might wait for finality, which means that you will wait 10 plus minutes, right, before including an executing message. And if you need to wait 10 plus minutes, it means that the sequencer needs to delay the inclusion of your transaction, right? And if you think about it, this is not compatible with forced transactions. Because if a user, the sequencer would like to delay a transaction for 10 plus minutes, but if a user forces a transaction, you have two options. Either you delay the whole chain by 10 minutes, or you accept reorgs. There is no other way. In fact, the thing that I have hidden here is that the validate message on this side will fail if it is called by a forced transaction. They will add a mechanism to inspect whether a transaction is a forced transaction or not, and if it is a forced transaction, it will revert. So this is the first version of the superchain interop. They will fix it in the second version. They have some discussion discussing on how to fix it, how to provide censorship resistance for cross-chain messages. But the thing is, in the first version, you have a risk such that if you want to bridge a token, you might be able to burn your token on the other side. But if you're censored by the sequencer, you will not get the mint transaction on the other side. So the sequencer will be able to burn your funds if he wants to. But hopefully, again, in the second version of this interop, you will get censorship resistance out of this. So this is it. The conclusion is, the trade-offs in these interop solutions are very different. The security is very different. And I hope that all these I invite all these projects to be honest about their risks. And I invite Optimism and the OP Labs to be honest about the risks of the first version of interop. But yeah, that's it. Security is important. Thanks.
All right, we'll take a few questions as we're getting the next speaker set up. Yes.
First of all, great job. Appreciate it. A couple questions. One, is this going to be published somewhere? Can I find this online?
I can publish it if needed, yeah.
Second, you mentioned cross-protocol level, most at risk for liquidity providers. Can you kind of expand on that?
Sorry, what's the question? Yes.
Those are the ones who are at risk.
Yeah. So, yeah, so anyone can be a liquidity provider. Like you can see that someone has deposited some funds. You can see this event. So you see that there is a user that is expecting some funds somewhere else. You can provide this service. Like you can give your funds to this user. And then the protocol will make sure to repay you with a fee with the funds that you have spent, right? And this is done with this settlement protocol, which goes through this optimistic protocol. So the thing is, if this was as secure as possible, this is mostly risk-free. You front your liquidity, you get a fee. This is a service you provide, and that's it. The thing is that if something goes wrong, like this protocol doesn't work correctly, it could be. So this is the thing that can go wrong. A user deposits some funds. You expect the funds to be relayed, somewhere else, but a liquidity provider lies and says, "I have filled your intent," but he didn't, right? So the protocol will refund the liquidity provider without them having spent anything. And if the protocol gives funds to this malicious liquidity provider, it will take liquidity from the honest ones, right? So this is a risk that the liquidity provider can take if this challenge protocol, this optimistic protocol doesn't work correctly. And another risk is, of course, upgrades. Like all the escrow contracts of the liquidity that you expect to get are upgraded, are stolen, you will not get your funds back, right? So that's the kind of risk that the liquidity providers are taking. Can I take another question?
Yeah, we have 2 minutes.
Yep.
What's your process for discovering vulnerabilities? Are you reviewing the code or?
So what we do at L2Beat is we just look at on-chain contracts. We really don't trust documentations, and you should either, because most of the time documentation talk about like future features that they want to have, not what's actually on chain. So an exception is this, superchain native interop is not live. So I didn't look at the production contracts. I looked at the spec. They have amazing specs. I invite all protocols to write specs as good as Optimism. But I can show you, like this was not planned. Can I, wait. No. What's the F? Okay. We have like amazing tools, internal tools at L2Beat that allow us to discover on-chain contracts, map a graph, and see all the values in a contract, see all the code. This is an internal tool. We will make it public so all of you can easily review contracts. But yeah, like we only look at on-chain code. We don't like documentations. Okay, thank. Yep.
If you were to say who's the most secure cross-chain
No one really. No one. No. Like they're all like as I said, both across like I can talk about like endgame protocols. Like I can imagine across like the endgame version of across being more secure than layer 0, but like today they're not. Right? It is possible to build a very secure across like protocol that uses canonical bridges for everything. Without these, challenge protocol, you can get rid of this if you, compromise, delays for security, and make everything immutable or like governed by the chains. But today they're not. Like everything is interpretable. There are more multisigs that can steal everything. So eventually maybe we'll get there. We will get there, but not today.